Oh, the same one.
Yep, same one.
Okay, that's.
Same data, nothing new to learn, all the
That one,
same
other
stuff.
one Called moderation two.
Yeah, moderation two is a separate example that we're not doing in here.
Okay.
But that example is on way there. Okay,
Oh, just a minute.
so, all right, so what we've got, if you remember, we've got role functioning, which we had transformed before. Now it's just 0 to 100. We are working with the untransformed set here. We've got PTSD, pain, and opiate use. Okay, and what we had expected was that pain is identified. Pain is a potential moderator of the relation between PTSD and role functioning, and opiate use moderating the relation between pain and role functioning here. So we got a couple of moderated effects. We have a couple of dichotomous indicator and two continuous predictors that we're using in our model. So what we're going to do, start off, here is our data set. With our there we go. Share screen. Okay. So first thing we want to do is we want to go through and center our variables. Okay. Why do we center our variables? Someone remind me. Yeah, Allison.
So that they're more interpretable.
So that they're more interpretable. Okay. So we've got pain, PTSD, and opiate use. Okay. Pain and PTSD are continuous, or we're treating them as continuous. Opiate use is dichotomous, 0, no use, 1 use. Okay. Now here, what we need to decide is, so if I center pain, I center PTSD. Remember that anytime we're working with a regression, any coefficient represents the expected change of the expected effect, unique effect of X on Y, holding everything else at constant at 0. But we get to choose what 0 means. And by centering, what we're doing is we're choosing 0 to mean the average of something or the mean of something. Okay. Now, what we get into is what do we do with this opiate predictor, right? Is it's dichotomous. Now, in this set, it's about 50-50. It's almost a perfect 50-50 split. Okay. This will not always be the case. Okay, so remember, we're centering opiate use the same way as we would center anything else. We're subtracting a mean, right? But Kate, you had asked about like, why would we center do we need to center dichotomous predictors? Why would we do that? Some things just to go through and think about, like as we start out with this moderation, I don't know if opiate use changes anything, right? But opiate use is involved in an interaction term. And we know that we have an interaction term set in our model. Now all of a sudden that 0 spot means something, and it'll start to change other things, right? If if pain and opiate use are in our interaction together, now all of a sudden those first order effects that we get in our model represent the unique effect of X on Y at everything else holding constant at 0. And so now it really depends on whether or not what 0 means for opiate use, because my unique effect of pain on role functioning is going to represent the association when everything is held constant at 0. And so now all of a sudden, like if 0, that's either if opiate use is scored or no opiate use is scored at 0, that's looking at the specific relation of pain with outcome for people who are not using opiates, right? Or if I flip it around, 0 is opiate use, it means the unique effect of pain on role functioning for people who are using opiates, right? Now, I don't know if this interaction of pain and opiate use is going to come up. And if it's not, because if we have an interaction term in there, it's going to change that first order effect a little bit. Even if we don't have evidence for the interaction, that interaction still lets opiate use change the unique relation of pain. And so when I'm starting out with this, what I'm going to do is I'm going to go through and center that, because what it then means is it's saying controlling for opiate use in the group, or averaging out or controlling for opiate use overall. Now my first order effect is going to be the unique effect of pain on role functioning, kind of averaging out across things, which if that interaction doesn't come out is actually kind of what I want. Like, so, okay, we're saying that opiate use doesn't technically, we don't have evidence that opiate use changes the nature of the relation between pain and my outcome. But if I set it to 0 or I set it to 1, it's going to tweak it just a little bit. And so for me, I would just rather have that be set as kind of the average. Okay. Now, as we start to go into simple slopes, that's when we're going to go through and start to play around with this a little bit so we can set the value of exactly what we want it to be and rerun that model. Okay. So on the question of do I center or how do I code my dichotomous variables, what we're going to do is we're going to dummy code everything. So it's going to be 0, 1. But there are other coding systems that we can use that do different types of things. If you want to get into that, there sort of Aiken and West do a nice job of talking about sort of different strategies for going through and coding these variables. When we get into categorical stuff that we'll finish up, that we'll get into after we finish this, now all of a sudden I've got a 3-level categorical variable where I've got condition 1, condition 2, condition 3. And what I'll do is I'll dummy variable those. If I create dummy variables, I for sure don't want to center that because then that's going to screw everything up. So it just requires you to know kind of what you're doing, what the objective is, and then make some adjustments there. Okay. So we'll go through and walk through this, and I'll sort of go through and explain, make sure that we got what's going on with stuff here. So what we're going to do first is we're going to go through and center our variables. So I'm going to go to data, and let's just make sure that also want to make sure that we go through, and normally we would have gone through and screened these first, right? We already did that at one point. We don't have any missing values. Want to make sure that you're not centering things at the mean of a set with missing values, because you want to make sure that you have the final set in hand before you start going through and doing this, right? So I'm going to go through transform or analyze descriptives, and we're going to look at pain, opiate use, and PTSD. Okay. To run that. Do we center our outcome variable? Nope, don't need to center our outcome variable. That's not necessary. If we're running a standardized solution, do we create z-scores of our outcome? So if we're generating a standardized solution, do we need z-scores of y when we do that? Yes, we do need to do that, because then that's a fully standardized solution. There are different standardization strategies, but if you want to manually calculate standardized coefficients, you need to have z-scores of y and z-scores of all your x's and then your interactions and stuff like that in order to do that appropriately. But when we're centering, don't need to center your y, don't need to center your outcome. Okay, so go through. We've got our means here, right? So what I'm going to do is I'm going to go up to transform, compute variable, and then I'm going to say centered pain is going to be equal to my pain severity score minus my mean, which is going to be 4.0702. Okay, I'm going to hit paste. All right. So now what I've got is I've got my output or my command to go through and center my pain score. Okay. And so what I'm going to do is I'm just going to go through, because it's going to be faster if we do this. So I'm going to go create a variable called centered opioid is going to be equal to opioid minus the mean is 0.5. And then I got my centered PTSD. Gonna be PTSD minus my mean is 50.93.
Just to clarify, that 0.5 there, that is like, because you have an even split of your dichotomous.
Yeah. 93. Yeah, so this is the mistake that people will commonly make with the dichotomous centering their dichotomous. So we center it the same way we'd center anything, right? What people will forget when they're doing stuff is that automatic, like, oh, it's a dichotomous variable, I just subtract 0.5. That's gonna throw things off, okay? So, but, so we've gone through, got my commands, and what I'm doing, I'm just creating 3 new variables, right? And these 3 new variables now should pop up right here, okay? So these are my new predictors, right? These are my centered predictors that I'm gonna now use sort of moving forward, right? And so now when I run, if I were to just run my base regression model here, nothing would change if I were to go through and do this, run these with my raw variables, except for what would be the one thing that would be different across those 2 models. The one with the uncentered predictors and the centered predictors, if we're just looking at just a regular simultaneous regression. Yeah.
What are intercept?
Beautiful. Our intercept is going to be different, right? Because our intercept is telling us the expected value of y when everything else is held constant at 0. With my raw variables, this is telling me the expected value of role functioning for someone who does not use opiates with no pain and no PTSD. In my centered solution, my intercept is telling me the expected value of role functioning for people who have average levels of pain, average levels of PTSD, controlling for opiate use. Okay. And so for our first order models, centering is fine, but it really doesn't change much of anything. Starts to become incredibly important in terms of interpretation for our moderation. Okay. So people understand what's going on with our centering. Did everybody kind of get sort of the centering piece of things?
Can you say the uncentered one again? I'm sorry.
What about that?
The centered one is like all the values, if it was average level, what's the uncentered again?
Uncentered is just raw. It's like whatever 0 is, right?
Okay.
And so this is something that can start to become tricky because maybe I've got a scale, Danielle, where 0 isn't actually a value. It's, let's say it's a 10 to 60 scale or something like that. But really what it's doing, what the model is doing is it's still evaluating everything as if that variable was equal to 0, when 0 is not even a real value on that scale, right? Again, with our first order models, with just our straight simultaneous regression, doesn't really matter because the unique effect of x on y actually doesn't depend on anything else. But as soon as we start working interaction effects in, now by definition, it'll change at least some, okay? So go through and I'm going to go through and I'm going to go analyze, back up, and always do this. I'm going to go through and re-examine descriptive statistics, but this time for all my centered variables. And why am I doing this?
For fun.
For fun?
Okay. I don't know, just like, don't make sure our means.
Yeah. Double check. What I should go through and I should see is all of these values should be very, very close to 0. Okay. Here we've got a little bit of residual on opiate use. That's because I actually have like, it's not exactly, I've got like one more person in one group than the other, but for our purposes, that's perfectly fine. Johnny, if you do this in Stata, you'll get like weird, infinitely small exponential things that's functionally 0, right? Always go through, double check this to make sure that you've got all of your variables centered, that we didn't make a mistake or sort of miskey anything. Okay, so we're feeling good here.
So I assume the mean that we're subtracting, we shouldn't be rounding that at all.
I mean, it doesn't probably matter a ton, right? So, I mean, here, just like whatever is reported in the output, right? I mean, you could,
Go
if you
in
wanted to,
with
you
the
could
full.
double click and it would be sort of all the way. You don't need to go through and do that. I mean, at some point, like it doesn't matter, it's just random digits after a certain point, right? So, when in doubt, rounding things to 3 digits is a pretty good way to go, so. Okay. All right, so we're looking good here, okay? Now what? I want to do now, we're gonna skip over and we're not gonna. In the handout. What I've got is we can run a first, just a basic regression with centered and uncentered variables to go through, kind of let you see what that's about. We don't need to do that. People are pretty good on what those models look like. Okay. What I am going to do though is now that I've got everything centered, I'm going to go through and I'm going to create my interaction terms. Okay, my first interaction is gonna be my interaction of pain and PTSD, okay? So I'm gonna say pain times PTSD is gonna be equal to product of its centered pain value times my centered PTSD, make sure I got my decimal point there at the end, okay? And I'm gonna have a second value. It's gonna be opiate by pain. That's gonna be pain, non-centered opioid. Is that good?
Sorry, I can't see.
You can't see?
I just the bulb for this side is like. I'm gonna move.
It's on that handout too.
I see your hand out perfect.
Yeah, it's, all of this is on the handout if you can't see this right here. So we're just going through and following this stuff here.
On the second page. Second page, thank you.
Yeah, Gabe, are you good? Are you?
Yes.
Okay, cool. All right, so do people see what we did? So we went through first centered all our variables, and now we're creating interaction terms using the centered variables that we just created. Thumbs up, everybody's with me so far? Okay, cool. So going through, run these. No errors pop up, that's nice. We go through, now I see my pain and my opiate use stuff here. Okay, now, okay, following along up to this point, feeling pretty good about stuff? Okay, cool. Now what we're gonna do is we're gonna go through analyze. We go through descriptive, or excuse me, not descriptives. We're gonna go down to regression, linear, okay? And now we're just gonna build our regression model. So role functioning is our outcome. We're gonna look at pain, opiate use, PTSD, all centered. And then my pain times PTSD and my opiate use times pain, okay? These are all gonna be my predictor variables here, okay? Then I'm gonna go into my statistics. I'm gonna ask for confidence bounds around my coefficients, because that seems like a good thing to have. R squared change, do we need to click R squared change? R squared change is for hierarchical models, it doesn't apply here, so we don't have to worry about it. I would like to see my descriptives, that's just a good thing to have. And partial correlations, right, those are giving me my effect sizes. And then I'm gonna request my collinearity diagnostics, just to sort of go through and have those included in there. We're sort of post screening, but we'll just go through and take a look and see what those are looking like, okay? So we're gonna go through and hit continue. Okay, yeah, if you hit save, like these are all your things that you can go through and save in terms of stuff. We'll walk through that with screening. We don't need to worry about that. Okay, so we'll call that good. We'll go through and hit paste. So here's my regression model, right? I've got output is role functioning. I got pain, opiate use, PTSD, times pain and opiate use times pain. Gonna go through and run that. Okay. So here we'll see, got my descriptives. Zeros for all of my first order effects, and then we've got mean, standard deviation, stuff like that for my interaction terms. That's fine. Here's my correlation matrix, right? If I go through and I take a look at correlations, we're seeing that my correlations between my interaction terms and my first order effects aren't all that bad, right? This is something that'll happen when you go through and center your variables. If we were to go through, and you could do this, you can go through and in an uncentered solution, you could just have your raw variables and create interaction terms that are not sort of based on center. They're just sort of pain times opiate use, sort of this and that. It's not going to change your highest order effects here, but what you'll see is a ton of collinearity in here, and some things will look real bad. It doesn't really have any actual impact on your outcomes in an OLS model, but it would if you're using different types of estimators, things like that. Okay, so just going through, taking a look there. Here's our R squared. Our R squared is actually pretty good, right? So it was saying the best linear combination of pain, opiate use, PTSD, and the interactions of pain and opiate use and pain and PTSD together is jointly accounting for close to 43% of the total variability in my role functioning variable. That's pretty good, not too bad, right? My F test here is saying that this is indeed a different value than 0, which we shouldn't be surprised. But then we get down into our coefficients table. Okay, and so what we'll do is pop this back up just so we can see a little bit better. Okay, so here's my main model. Okay. So Mesa, if we're looking at my main model, what am I seeing down here in terms of what we're seeing in this model? Where do I have evidence for effects?
You mean like the standardized coefficient, the beta?
Well, we're looking at p-values right here, just to go through and identify effects. Where are we seeing effects?
Pain,
Okay.
PTSD.
Yeah.
The interaction between pain and PTSD. And maybe opioid times pain.
Yeah. OB. I mean, 051. Or tie goes to the runner, we'll call that fine, right? Like some reviewer might get bent out of shape out of that, but like it's a trivial difference, right? So we'll go through and explore this. Okay. So if we're going through, can someone tell me very literally what does this coefficient? So we've got an effect for pain. Someone tell me what is the interpretation of that coefficient for pain? Abby?
For every, oh wait, no, hold on. I feel like I'm thrown off now because it's centered, I take it back.
Okay, well, centering matters a little bit, but Johnny, do you have an idea?
Is it for every 1 unit increase in role functioning, we have a -10 decrease in point reduction in
Flip that around.
sorry,
For every unit increase in,
pain, we have a 10-point decrease in role
Right.
functioning.
okay, so. Exactly right. Only thing I would tack on to the end of that is holding everything else constant at 0, which means averaging across opiate use for people with average levels of pain. Okay, this is where things start to get tricky because pain, we have evidence of effects for pain and PTSD. Okay. Can we just straight up interpret these then the way we did in our first order model? No, we can't, because now all of a sudden, because we have these interaction terms, pain and PTSD are both involved in interaction terms, and 2 interaction terms that are that we're identifying as we have evidence for interactions here, right? So now all of a sudden, these are conditional effects, right? The effect of pain on role functioning depends on opiate use, right? And also on PTSD. The effect of PTSD on role functioning depends on pain, right? So now all of a sudden, the values of my other variables start to change and sort of start to impact this. So as I'm looking at this, I would say this is the unique effect of pain on role functioning at average levels of PTSD, right? This is the unique effect of pain on role functioning at average levels of PTSD. I guess, and this is the unique effect of pain at average levels of role functioning controlling for opiate use. So the rolling, sort of taking that sort of on average, okay? So now all of a sudden, all of these first order effects start to have very specific interpretations. If I were to shift what 0 meant for pain, opiate use, and PTSD, would these values change? If I were to change in my model, if I were to change where the 0 point was for pain, opiate use, and PTSD, in this same model, would these values change? Yep, they're going to be shifting around, right? Because now all of a sudden, we're talking about the unique effect of pain on role functioning for a different level of PTSD. And we know that because we have a decent evidence for an interaction here, we know that the effect of pain on role functioning depends on PTSD. And the effect of PTSD on role functioning depends on pain. These two, we've tied these two things together. So I can't talk about one without knowing something about the other. Okay. And so, Kate, this is where, when we're talking about centered opiate use, right? I don't know if opiate use is going to be involved in interaction. It turns out it kind of is, right? But for this first model, what this effect of pain is telling me, this is the effect of pain on role functioning across people who are controlling for opiate use, or kind of averaging or ignoring across opiate use. This is that overall effect of pain controlling for that for people at average levels of PTSD, right? So if I were to go through and just include opiate use as a dummy code, 0, 1, now all of a sudden that starts to change that coefficient, right? Because then if it's just their straight code, then we're talking about the unique effect of pain on role functioning for people who are not using opiates. Or if we flip that around, reverse code that, this is a unique effect of pain on outcome for people who are using opiates, right? So what we can start to do when we're looking at these simple slopes is we start playing around with 0 to give us the actual answers that we're really interested in, okay? So people see kind of what's happening with sort of in our model here.
I
Yeah,
think
take
so,
it.
I just want to clarify, so those are conditional because we have that interaction, we can't
Yeah.
just say, okay.
Oh, perfect. And so just like when we were working with factorial analysis before, right? I can't really give a strong interpretation of these things because they all kind of depend. If I start shifting levels of PTSD, pain, opiate use, all these are going to change around, okay? Now, the thing is what we would do if these, or we didn't have evidence for these effects here, right? We'd say, well, it doesn't look like the effect of PTSD on role functioning is conditioned on pain. We don't have evidence for that, or that the relation of pain with role functioning differs based on opiate use. We don't have any evidence for that, right? So then we could say, okay, we can go down through and interpret these. Only caveat there is because these interaction terms are in there, mathematically, they're going to change a little bit. It might not change in what we would say is giving us evidence of a meaningful, but it'll change some, which is why I always like to start out with my first model before I do anything else. If I've got a dichotomous indicator like, let's say, biological sex, opiate use, some other dichotomous variable, I'll generally go through and just center that in the first model. Because then I can say, even if these things don't turn up, like, okay, this is a unique effect of X on Y once we sort of control for that other thing. Now it looks like this interaction doesn't turn up, so doesn't really change, but I feel like I have a more precise estimate if we're just like taking the average as opposed to saying this is a unique effect of X on Y for women, right? Or for men, or for sort of whatever our variables are. Yeah.
One more. If I was writing this up, I would just focus on those interaction terms since pain and opioid and stuff are in that interaction. I just wouldn't even
Right
Yeah.
about the first. one.
Yeah, I would probably do that. Now, this is the thing, like, that's probably the way to go through and go about things. Now, there are circumstances, right, like people say, well, you can't interpret a main effective in the presence of an interaction. You can't interpret it cleanly, but what I might say is like, hey, overall, this thing is changing. However, the extent to which it changes is kind of dependent on this other thing. If there was a reason to go through and make a strong argument, we talked about this last semester. If I'm looking at the association of smoking with outcome dependent on age, right? I get a main effect of smoking, like, hey, yes, smoking's bad for you. Now, how bad it is for you depends on age. As you get older, it looks like it gets worse. So there's an interaction here we're going to talk about, but overall, smoking's bad. So I want to get that out of the way first, right? But that's kind of a sort of depends on what you're talking about. So generally, what we're going to do is if the reason we put these in, if we've included interaction terms, the assumption is that we put those in because we want to talk about them. And so generally what we're going to do is like, oh, hey, we might say that when we went through consistent with hypothesis, kind of an interaction of this and this, and then hold off on that. So for your problem sets, you don't need to go through and like start talking about these necessarily in the presence of the interaction. You can just say, note that there was an interaction, then we went into the simple slope stuff. Okay. So other thing too, is if we're going through and taking a look at your partial coefficients, your semi-partial coefficients that are using those as interpreting as measures of effect size, right? You can go through and square these and just kind of talk about magnitude of effects and things like that. Okay. One last thing I'll talk about here before we get into actually jumping into simple slopes. This is a philosophical orientation. I think I'm right and other people are wrong, but that's how we think about things. Sometimes, I just reviewed a paper that I thought wasn't too bad, and then it got rejected from the journal that I reviewed for it. I didn't think, that seemed reasonable. One of the things the reviewer got real mad about is sometimes you'll see with these moderation analyses, people say, hey, you can't do it the way you just did it. What you need to do is you need to go through and you need to put your first order effects in first. And then in the second step of your hierarchical regression, that's when you sort of include your interaction terms. And what you shouldn't do is interpret these moderated effects unless, in this case, these two interaction terms go through and result in an increase in your R squared. So does the inclusion of these interaction terms add additional variability in the model? And if that you don't have that, find evidence of that R squared change, then I'm saying that you can't go through and interpret those interactions because they don't add additional variability to the model. Okay. Any thoughts on why I might not care for that argument based on what we've talked about?
State your argument again, sorry.
Yeah. Oh, hold up, Jim.
I don't know. This is like backstory. So I ran like a moderated mediation for my project, and there was no direct effect. Cassie and I were talking about it, and she was like, there is argument against, because before people were like, oh, there has to be like a direct effect. But now like people are like, it's okay if there's, I don't know if that is relevant.
Not exactly, but also yes, like, oh, you can't interpret interaction in the absence of the main effect. That's ridiculous. That's just a misunderstanding what the hell's going on, right? If I get invisible ink.
I don't know what you're talking about. I can see it just fine.
Right. In my mind. Okay.
Going colorblind?
If I get an interaction that looks like this and that, where does at average levels, what does that association look like? Right down there, right? If I just look at the effect of X and Y, right? I'm saying that X isn't related to, there's no association between X and Y here. But if I have this interaction term in there, I see, no, there very much is an effect of X and Y, it's just the opposite, whether or not we're talking about one group versus the other. For this group, we have a positive effect. The other group, we have an equally strong negative effect. We just look at everybody, it cancels each other out, so we don't have any effect at all, right? That doesn't like, this is a super cool effect to find, right? To suggest that like, oh, you can't interpret that because there's no main effect in the main model is asinine. Yeah, that's not a real thing, right? So, but a good point, not exactly what we're talking about here.
I don't know if this is right at all, but so I've definitely done it where I have the interaction in the second step of the regression before. Don't know why I did that. I think I was just told to do it.
Yeah.
Is it something to do with how it changes how we calculate change in R squared?
Not so much with that. The thing is, it's a fine way to do things if you want to do the things that way, right? The problem is that in psychological science, is our goal ever to maximize our R squared? Like the ultimate goal of what we're trying to do is sort of make sure we account for as much variability in our outcome as possible. I mean, it's good, it's not a bad thing, but oftentimes we're testing specific hypotheses. My theory says that the effect of this, the association of this thing with this outcome is going to change depending on who I'm talking about, or sort of this level to this other variable. I don't care, like, I'm not really all that interested in sort of what my R squared is, right? And so to have that be a barrier against, like, it's pulling in something completely irrelevant to what I'm trying to do, and sort of having that be a criterion for interpreting my effect, right? So people will say, oh, what you have to do is you have to put those in your interaction terms at the second step. And then if those don't go through and contribute to your overall model, then you can't go through and interpret those even if they're popping up, and that'll happen sort of a fair amount. Interaction effects are small. We're going to talk about that. They usually don't account for much variability in my outcome unless they're really big and obvious. But a lot of the stuff that we're looking at is really subtle. Our measures are also garbage and packed full of error, which we'll talk about how this all impacts things, right? So I'm very much against sort of having that be the gate to be able to go through and talk about my interactions. And I'll fight with people in terms of make an argument in an appropriate way to try and suggest that maybe that's not something that we need to do, because it doesn't make any sense, right? Like, so sure, if we're trying to predict revenue on an outcome, then yeah, that's something we need to be concerned about. But for these models, it doesn't really matter. So if you've got a reviewer who's like, no, you have to run this as a hierarchical model and do X, Y, fine, whatever. It doesn't change anything, right? So just go through and do it. And hopefully it's enough to make that R squared change value sort of come up. You're like, okay, so there you go. You can pat them on the head and say, oh, it's an excellent example. Or suggestion, we're glad you gave it, and we did it. And here's the same goddamn thing I told you in the front end, right? But yeah, sometimes people get really rigid, and then if you don't, right, or if it's some marginal thing, then you make the strong argument like, hey, purpose of the study isn't to try and maximize the R squared. The purpose of the study is to test this very specific hypothesis I have about sort of this moderation effect. So respectfully, I'm not going to do that. I'm going to keep what I'm going to do, because like, I am the prize, dude. Like, this is what I'm trying to do with this. Okay. Yes.
I have just a quick question, because I know we're about to go to like the simple slopes part, and that is to look at like our interaction.
Yeah.
Right, okay, so what if we don't have an interaction?
Yep.
Do we not go past this?
Nope.
Is that just?
No reason to, right? I mean, you can go through and you can plot simple slopes for it. Probably what they'll do is they'll look pretty parallel, right?
Yeah.
And they might not be, so that, but based on the interaction, we don't have evidence to suggest that the effect of X on Y depends on my moderator, right? And so in the absence of that, there's no reason to really test the simple slopes, because I don't have an interaction to really talk about, right? But remember, when we're going through and looking at this, if I have an interaction, if this interaction pops up, by definition, this is saying that at least within this model, the effect of X on Y, the effect of X1 on Y depends on level of X2, or the level of X2 on Y depends on X1. They're interchangeable. You can talk about them either way, right? So here I could talk about, in the presence of these two interactions, I could talk about the unique effect of pain on role functioning across sort of opiate use or non-use, or I could talk about the unique effect of opiate use on neural functioning at higher low levels of pain, right? Now, last thing I'll say before we get into this, and this is kind of a little interpretive thing, hopefully you're coming into this with some sort of a priori idea, right? Why, given this output, might I not choose to talk about the effect of opiate use, the unique effect of opiate use on neural functioning at different levels of pain? What's that?
It's a dichotomous variable. Like,
Well, dichotomous, that's actually fine. It actually makes the simple slopes pretty easy and straightforward. So, or I'm not too worried about that. Allison?
Your P value is 0.775.
Yeah, it starts to become hard sometimes to talk about the unique effect of X on Y at different levels of moderator if I don't have any evidence of a direct relationship anyway, right? Basically, this is the simple slope of pain on functioning at average levels of PTSD and at sort of zeroing out or controlling for opiate use. This is the unique effect, or this is the simple slope of PTSD at average levels of pain controlling for opiate use. This is the unique effect of opiate use on neural functioning at average levels of pain and PTSD, but opiate use doesn't. And if I go through and change this from 0 to 1, opiate use never has a unique effect of a unique effect on neural functioning, at least on average levels of things. And so sometimes your hand is a little bit forced in terms of how you conceptualize this, because we can have something that's involved in this interaction that will never have a unique association with your outcome, but it's changing the nature of sort of the other thing, right? So here, it starts to become hard to talk about the effect of opiate use on neural functioning when we don't have any evidence of opiate use on neural functioning to begin with, right? So sometimes how we conceptualize the interaction is kind of data driven, because otherwise it starts to become hard to talk about, right? But hopefully for the most part, we have strong a priori ideas about what's our base relation, what's the thing that's been determined in the literature over and over and over again, and then what's the thing that we're trying to go through and set boundary criteria for. Under what circumstances is this thing associated with outcome? Is it always above, or is all for always and forever the same thing, or does it change based on something else? Yeah, Julie.
Is that why you mentioned earlier that like the opioid use is like control?
That's more just like a function of how we set this model up. Okay. Yeah, and that's just sort of tearing out, because no one actually in this set has a value of 0 for opiate use. It's either -5 or 5, right? 0 just means kind of averaging it out. All right, questions?
This is just super brief.
Yeah.
On our problem set, you probably don't want us doing it in a hierarchical model then.
You don't need to, it just adds unnecessary complications, just going through and doing it this way.
That's what I'm using.
What's that?
I said it's just what I'm using.
Yeah, no, and it's fine, functionally, it doesn't matter or change, I mean, it's an additional thing to go through and talk about that. Like, do I really care if it increases like the overall variability in my output by 1.5%? Like, well, I guess for me, in terms of thinking, like, it doesn't matter, because I don't care about that. It doesn't influence for me whether or not I'm gonna interpret these anyway. So you can do it, but again, that's where in that lecture piece of that lecture that you watch, people get real excited about hierarchical models. The only unique thing you're getting out of a hierarchical model is an R-squared change value. By the time you get to that last one, it's the same thing as this, right? Which is why in that last set talking about, hey, if I go through and layer these things in, how does that relate to a hierarchical model? It's the exact same that we would get. The only thing that we would get is an R-squared change value with the addition of each predictor. And if that's important to me, cool. It's hard to think about a situation where it would be kind of the thing I want to spend most of my time. All good questions. Are you comfortable with this? Okay, cool. So, next what we would do, and we did this in lecture, so we won't spend a whole bunch of time here. But what we would do is we'd go through and take our model here, right? And this is just coefficient that we pulled from our table and going through and factoring down my equation, right? Go through and factor down my equation. I go through get my simple slopes equation for PTSD and role functioning at low pain, PTSD and role functioning at high pain, and then go through and I plot this out on my graph in SPSS, or excuse me, in Excel. That's kind of what this is looking like here, right? I just set up this model. I go through and I've got, you know, plugging those values in and letting Excel calculate that. Going through plotting this, always remember to make sure that for your make sure that your graph is flipped the right way. Here we've got low pain and high pain. Pain is your base variable, and this is your moderator. That's actually not what we did. Making sure that things are sort of flipped the right way you want them to be, right? So go through and plotting these out in PTS or in Excel. And so we've got, this is all the stuff that we did just by hand factoring from our full model. As long as we're down with basic algebra, we can get there. And we know exactly what our intercept is going to be, what our slope is going to be at high and low levels of pain. We generally setting that as a standard deviation above and below. And what's nice with my centered variable, everything's centered, standard deviation above is just standard plus standard deviation below, negative standard deviation, makes it really easy. Okay. Same thing if we go through and plot out for, okay, well, so we do this, okay, so we went through, we're going to focus on the interaction of pain and PTSD here, okay? What's the one thing that we might want to know that we don't get from factoring? We already know what the equation is going to be, right? And we already know what the simple slopes is going to be. What's the one thing we're not getting out of these hand calculations that we're doing here? Do I know if I have evidence for an effect here or evidence for an effect here? No, we probably want to test these, right? Now, remember that this is all arbitrary, right? There's nothing special about a standard deviation above or a standard deviation below. We use it because, like, on average, we're expecting at least some of our sample to fall around these values. So it's an okay, it's not a bad situation or a bad, they're not bad points to pick. They're better than a lot of other things that we could use, but there's nothing special about this. So what we might want to do is say, like, okay, well, if these are the points that we're going to pick, do we have evidence of a relation here or evidence of a relation here? If I get someone who's not super savvy, they're like, oh, well, it looks like pain and PTSD, or excuse me, PTSD has a positive association with role functioning at low levels or at high levels of pain. Like, well, it's tipped up. I don't know that that's different than zero. Let me go through and test this. Okay. So what we're going to do then is we're going to go back to our back to SPSS and recalculate some variables. Okay. What I'm going to do is I'm going to create a couple new variables to help correspond. So my moderator here is pain, right? So what I'm going to do is I'm going to go through and recenter what pain means, right? Or where zero is at for pain. So what I'm going to do is I'm create a new variable called low pain. And low pain is going to be pain plus a standard deviation. And it plus a standard deviation 1.34187. Okay. And this is going to be my variable for low pain. What I'm going to do is I'm taking that centered pain variable, and this needs to be centered pain, but that centered pain variable, and I'm just recentering things so that zero is a standard deviation below the mean. And I'm going to do the same thing I'm gonna reset this, so standard deviation, pain, 0 is a standard deviation above the mean, okay? So I'm at two different variables. Now here, again, low pain, it seems like I should be subtracting the standard deviation. I'm not, I'm adding a standard deviation, right? Because remember, what we've got here is what I want if my 0 is my mean and I add 1.34 to everything, now all of a sudden, what is my mean value for this variable? My mean value is now 1.34, right? So where does 0 fall relative to that standard deviation below? Okay, here for high pain, I'm subtracting a standard deviation. My mean for centered pain is 0, and I subtract a standard deviation from everybody. Now my new mean for this is negative 1.34. 0 falls a standard deviation above. Okay, so what we're doing is we're just shifting this variable around so that 0 corresponds to high levels of pain or low levels of pain. Okay, and so if we go through and we create our new variables here.
Hey, Josh, I just have a quick question. Why, I feel like like, is there a reason why some people would use like z-scores? Like, do people, instead of centering the variables,
Yeah,
like to do this?
yeah. No, Kate had brought this up last time, and this is a very good question.
Okay.
I can read your response that you sent me.
Yeah. So here, just to go through and double check, right? So I just looked at descriptors for my high and low variables. Yeah, so here we've got low pain. The average score at low pain is 1.34, which means 0 is below the mean. Here we've got the average scores for high pain is negative 1.34, means that 0 is above the mean, right? So that's just kind of what's going on. To your point, Haley, yes, if I go through and I standardize everything, if I standardize my output or my dependent variable and standardize z-scores for all of my predictors, and then create interaction terms with those z-scores, what I'll get is a standardized solution. And it's actually quite nice because then high and low values are my z-score for x -1 +1. It works out pretty slick. The thing that we wouldn't get with that is those unstandardized coefficients. I wouldn't have any unstandardized coefficients in my model. And by convention, we generally want to present those so that people can sort of go through and say, okay, if they want to give a literal interpretation for every unit increase, what's the expected change in my outcome? The other thing to remember that if I'm looking at comparing across studies, my unstandardized coefficients are the better thing to compare across studies than my standardized coefficients. Because if I get samples with different variances, that's going to change my z-scores. And so I kind of got an apples and oranges situation with that too, right? So really what we probably want to do is both, right? But yeah, if you go through and just run if you just run z-scores to start and then just run everything with the z-scores, kind of simplifies the math a little bit. And remember that that's what you would need to do anyway if you want to get appropriate standardized terms for your interactions. So you probably end up, if you're sort of running this, probably want to do both. So yeah. But if you're just interested in standardized scores and want to just put down a standardized solution, you could certainly do that. Other questions? All right. So we've got our new standard, or our recentered pain at high and low. Now what I'm going to do is I'm going to go through and I'm going to create new interaction terms now for both of my interactions that include or incorporate pain. So here we'll call this OP times opiate and this PTSD or low pain PTSD is going to be my low pain variable. I'm centered PTSD. And then I have to say Opiate use is gonna be my low pain variable times centered opiate use. Right, so I got my two interaction terms for pain recentered at low values. And then I'm gonna go through, do the same thing. High pain. High pain. And then drop in high pain here. High pain here. Okay. So what I've got, because I've got two interaction terms that involve pain. And what I've done is I've taken, sort of what I'm gonna do is I'm gonna run a new model where I've shifted the zero value of pain to correspond to a standard deviation below the mean, right, with low pain. And so I've created a new variable, low pain, and so then every variable, every place in my model where pain was, I need to recreate something so that that low pain variable substitutes, and then we can't cross and mix and match, they'll destroy everything, okay? Same thing then, I've recreated a new variable that corresponds to 0 being a standard deviation above the mean for pain. Then what I need to do is go back through and substitute that new high pain variable in for every instance where pain was in my model, okay? So in our case, we have the first order effect, and then we've got our two interactions, okay? So if we go through, run all of that, right? Into my output, now I'm getting all sorts of fun stuff. Here's centered pain, centered opiate use, centered PTSD, pain times PTSD, opiate use times pain, low pain, high pain, low pain PTSD, low pain times opiate use, low high pain times PTSD, high pain times opiate use. A lot of stuff to keep track of, right? So there's a lot of moving parts with this, right? But what I'm going to do now is I'm going to go back up to analyze. You go to my regression model, and I'm going to go through and reset this. So now I'm going to start with low pain, centered opiate use, centered PTSD, right? And then I'm going to put my low pain PTSD and my low pain times opiate use, swap those in. And if I paste this, what I'll find is the same model I had above. The only thing that changed is me just swapping things out here. So now instead of pain, I have low pain. Opiate use is the same. PTSD is the same. Instead of pain times PTSD, I have low pain times PTSD. Instead of opiate use times pain, I have low pain times opiate use. It's the same model. We're just shifting. We're just substituting that one pain variable in there. Okay. And then what I can do is I can go through and take this, copy that. And now all I'm going to do is going to go through, instead of low pain, I'm just going to pop in high pain. So I've got high pain, opiate use, PTSD, high pain, PTSD interaction, high pain, opiate interaction there. Okay. So one thing that I've learned from experience that's really helpful with this is being mindful of how you're labeling your variables. If they're kind of easy things to go through, and then it makes this a little bit easier to sort of go through and do. Label them however you want to, right? But you'll see here when we run this right here, my two. Again, here we've got low pain, high pain, and then my 4 new interaction terms that I've gone through and created here, right? And then I'm just running the same regression model. The only thing that changes across these two models is where I'm shifting around my pain point. Okay. So if I go through and I run these analyses, I get one model here that is my simple slopes for PTSD at low pain and my simple slopes for PTSD at high pain. Okay. If I go through and I take a look at what I've got here, So remember what I'm doing is my hypothesis is that the association of PTSD and functioning is going to depend on levels of pain. I had evidence for that interaction in my first model, right? Which tells me that the association of unique effect of PTSD on outcome is in fact conditioned on pain, right? The level of pain people are reporting does matter. So I said, okay, I'm going to go through and rescale pain so that in one situation, 0 corresponds to low levels of pain, another one, 0 corresponds to high levels of pain. Then I go through, look at my models. What I should see here is that my interaction terms, should my interaction terms change at all? Nope, shouldn't change at all. Your highest order effects shouldn't change. And if we go through, look at our p-values, look at our actual coefficients, if you refer those back up to the previous model, those haven't changed, right? Should my R-square value change? Nope, R-square value doesn't change. What is going to change is all my first order effects, okay? So here, looking at my my model for, we've got low pain, right? What am I looking at in terms of my simple slope here? Like what's the only thing that I'm interested in this model? If I'm saying that pain impacts the unique effect of PTSD on role functioning. What's the simple slope I'm trying to get out of this first model? Simple slope for what? Okay, let's see that if you look at low pain and high pain, the effect of pain doesn't change, right? I'm just switching I'm switching the 0 point, but the unique effect of this, because across these models, 0 point for opiate use is the same, 0 point for PTSD is the same, so none of that changes. So my effect of pain stays constant. What am I interested in? Not for this one.
Yes.
PTSD, right? So if I look at this, the only reason I'm running these models, remember, is to try and get a GDP value for this and for that, okay? So if I go down through and I take a look, I see that at low pain, right? At low levels of pain, what's the unique effect of PTSD on role functioning, holding pain constant at a standard deviation below the mean? Well, I see that I get an effect of PTSD. Here's my coefficient, here's my p-value, here are my effect sizes for that. And if I go through and I take a look, I see my constant is 23.518. Coefficient is negative 0.413. If I go back through what I got within some rounding error, right? This tells me that if this is a mismatch, something's gone wrong somewhere in my model, okay? And so do I say that I have evidence for a negative relation between PTSD and role functioning at low levels of pain? Yep, I sure do, because I go in through and I can take a look at this. Now you're saying opiate use changes around because opiate use is involved in interaction with pain and things. Ignore that, we're not interested in that. This is just getting a simple slopes for PTSD. And then at high levels of pain, right, I go through, take a look. Let's see, do I have evidence for a unique effect of pain of PTSD on role functioning at high levels of pain?
Yes,
Do we ever look at code?
right, I was looking at the significance of the
Yeah.
interaction.
Okay, so do I have evidence of a simple slope of PTSD on role functioning at high levels of pain?
I think I'm lost. So the question is, are you asking about the interaction between high levels of pain and PTSD?
Interaction is going to stay the same. Interaction never changes. Okay. Looking at the simple slope. Do we have evidence for a unique effect of PTSD on role functioning at high levels of pain?
How is what you are saying different than explaining an interaction?
Yeah.
Well, it is an interaction. The thing is, what we're looking at is when we're going through and with this model is we're saying, what is the unique effect of this and that at different levels, right? We know because we have an interaction effect that it changes, right? What we're saying is specifically, if I hold pain constant at a standard deviation above the mean, do I have an effect of pain then, right? And so if we look at this model, we have an effect of PTSD on role functioning at high levels of pain.
When it's centered.
So what's my p-value here?
Yeah, so I said like the interaction is significant.
Yeah,
Is
but
that-
the interaction is the same always. Interaction term won't ever change.
Okay,
That's how we know if our model is working out, is because if that interaction term holds, right? What we're interested in is both of these, is this effect of PTSD, the conditional effect of PTSD. Do we have a conditional effect of PTSD here?
no.
No, we don't, right? What we're saying is that if we hold pain constant at high levels, standard deviation above, do we see an effect of PTSD? And here we don't, right? If we hold pain constant at standard deviation below, do we see an effect? Now we do, right? And so when we're going through and looking at this, what we're trying to do is go through and say, at different levels of the moderator, are we seeing sort of a main effect, or excuse me, a simple slope effect sort of on stuff, right? So you're right, Olivia, when we're saying this, that this interaction is there, that interaction is always going to stay the same. Interaction is saying that the effect of X on Y changes depending on what my level of my moderator is, right? What we want to do with the simple slopes analysis is then say, well, if we arbitrarily pick at low levels, at high levels, are we getting evidence of an effect, right? And so if we go back through and take a look here, we're seeing that for at low pain, or excuse me, high pain, I've got a constant of 3.44 and a simple slope of 0.043. And if I go back through and take a look at what I hand calculated from this, I'm seeing that I got the exact same thing. Okay, real quick, is that kind of help clarify exactly what we've got going on with this?
I mean, yes, it makes sense, just the way you were wording it, at least to me, and I think to Lindsay as well, sounded like you were describing an interaction.
Okay,
So I think it was just like a wording.
okay, cool. But do we understand
Yeah,
kind of
no,
what?
I get that.
Okay, cool. Yes, Johnny.
I just had a quick question. You said, briefly like a interpretation of, with the low pain.
Uh-huh.
And I was curious if you could repeat that.
At low pain.
At low pain, yeah.
Okay, at low pain, we're saying holding pain constant at 0, right? Which is all what we're looking at. But here, what we've done is we've rescaled pain so that 0 represents a standard deviation below the mean, right? And so here, if we do that, we're saying that we do find evidence for a negative association between PTSD and role functioning at low levels of pain, okay? But if we would play around with my pain variable and set that 0 point to a standard deviation above the mean, if we do that, now all of a sudden we don't get an association here. And again, what we're saying here is that our interaction term overall says that if we have evidence for that interaction term, we're saying that the association of X and Y is depending on levels of my moderator, right? And if I go back through what's the effect here? What about at average levels of pain? Where does that fall in this plot here? What's that? Well, no, average pain is plotted here. Where would it, if we were to draw it? Yeah, what are you thinking, Gabe? Yeah, it just bisects this, right? This is what you'll see sometimes when people are presenting simple slope stuff. They'll present at low standard deviation below average and high, which is a fine way to do it. But I know that because we're assuming a linear relation here, that the average is just going to bisect those two anyway. Okay, so I usually don't play around with it. You can't, right? But again, what we're doing with this is just going through and looking at everything that you can get here, you can get based on just hand calculations from your overall model. The one thing that we can't get is whether or not we have evidence for what these coefficients, or excuse me, whether or not we have evidence for a non-zero relation here, and then an effect size associated with that, right? And so that's where we've gone through, and that's what we're getting off of this. And again, the only thing that we're doing is we're just playing around with 0 points on this. Remember, I said 0 is critical in terms of understanding our regression models and in terms of interpretation. All we did is we created new variables where 0 is at different points on that pain scale, and then created corresponding interactions, and then going through and taking stuff. Okay, yeah.
I just wanted to clarify, is
Yeah.
the reason that we, like, when we ran this model, the reason that we included like centered opioid, even though that's not what we were looking at, is just because it's part of like the original like overall model?
Mhm.
Okay.
Mhm. And so here, for this simple slopes, opioid isn't involved in this one, right? We're just looking at the moderating effect of pain on PTSD at high and low levels, or excuse me, PTSD on role functioning at high and low levels of pain. So we're leaving opiate put, right? What we'll do when we come back is once we've got this all put together, now we're gonna go through, flip around and start playing around with opiate use. But that actually gets a little bit easier because it's just a 0-1 variable. Okay. Yeah, okay.
Tacking on the same,
Yeah.
essentially the same question. So, we've got the constant of opioid as well as that interaction there with like pain that involves opioid. Those are both in there just to keep the model like
Yeah,
consistent.
Good, yeah.
Okay.
When we're going through and looking at our simple slopes, you always, all the same variables still need to be there. All the same terms need to be in there. We're playing around with the scaling. But Kate, what would happen if you didn't have, if you're like, oh, I just want to look at the effect of pain and PTSD, so I'm just sort of gonna go through and look at role functioning on pain, PTSD, and the interaction. Now we've got a different model, right? So we're keeping the model identical, we're just swapping different terms out. Okay. And so if you were to do that, you would get, well, your interaction terms would change. And if your interaction terms change, then you know you've made a mistake somewhere, right? Your R squared would change until you didn't know you made a mistake somewhere. So the only thing we're fooling around with is that moderator. Okay. Haley, do you have a
Yes,
question?
I did. So. Okay. When we're looking at the simple slopes, we're just saying that if we hold pain constant at, for the low at a standard deviation below the mean. There's a negative association, like with ours, there's a negative association on role functioning.
So as PTSD increases, role functioning decreases.
Yes.
Okay, but if we hold pain constant at a high level, standard deviation above, what do we get? We have an evidence for an effect of PTSD at that point. No, we've kind of floored out, right? Now, PTSD isn't related to pain. If we hold pain constant at high levels, now what we've got is no association of PTSD with role functioning. And probably what's happening, if we're working with people with high levels of pain, they're just kind of floored out. It doesn't matter what my level of PTSD is, I've just bottomed out. Yeah.
So I just wanna make sure I'm understanding. So because we have evidence of an effect for the holding pain constant at the low level. But we don't have an evidence of effect for holding pain at a high level. What we essentially like kind of tying all that stuff together is that so that the association of PTSD and role functioning is impacted by the varying levels of our moderated pain.
And you already knew that based on the interaction. The fact that the interaction was had a low p-value, that you identified an interaction, tells you already that the effect of PTSD on outcome is dependent on pain, right?
Okay.
Simple slopes is just a way to start to go through and tease this apart and say, okay, so what does this kind of look like, right?
Okay.
And so that's where we're going through with at least this approach, how we're going through and teasing that apart.
So now we're able to say that like, we're able to tease it apart to the point of it depends on the levels.
Yeah, yeah, yeah,
And so had it been significant at the high level?
Yeah.
That would mean just that there's like a mediating effect at all levels?
okay. Moderating or
Or, yeah,
mediating,
sorry.
so pull that out. Nope, and that's what will actually happen quite a bit, right? Is what we'll get, is we'll get evidence of. Say we have something that looks like this. And then something that looks like this, right? And we get p-values that are saying like both at high and low levels of pain, we still have evidence for an association with PTSD and neural functioning. What's the caveat though?
I guess regardless of pain level.
Yeah, so regardless, it's related. But the relationships, the association is much weaker at high levels of pain than low levels of pain. It's still related, but it's just not as coupled as strongly, right? At low levels, real strong association. High levels, not so much. And honestly, with the type of stuff that we do, this is often what these simple slopes effects will look like. They're like, yeah, really strong and then kind of strong, right? But if we went through and just in thinking about this in terms of a linear function, if I wanted to go, say, 2 standard deviations above the mean, what would that slope look like? And it's like this, and 2 standard deviations below, looking like, well, maybe not quite that much. But something like this, right? It's linear, right? So depending on where I go through and how far above or below the mean I want to get, it's just going to go through and change it that way. So this is why we go through and pick a standard deviation above and below, because that's just kind of what we do. They seem like reasonably representative values. But you could look at 5 standard deviations above and below if you wanted to. It's just going to go through and change that in a linear fashion. Okay. Okay, cool. Let's go through, have a break, come back at 3:45, and then we'll jump in and take things from there. Yeah. No worries.
Okay, so you were talking about like, yeah, it's just right, smart. Are we, we're looking at those and those.
Yeah, so this is your interaction.
Oh,
That's your interaction, right? So here's your low pain, your opiate use. Yeah,
Sorry, not the interaction.
not the interaction. Got that?
Okay, yes. perfect.
Okay,
Thank you.
no problem. Yeah, this is the tricky analyses. There's a lot of sort of different moving pieces
I
and
think I
parts.
just screwed out when I was doing it, because I can see this one.
Okay, did you forget to put that one in? Okay, yeah, go back through and take a look. The thing is that it gives a nice template in terms of these are the things that sort of need to sort of be in there, right? So once you kind of get the system down, it starts to become a little bit easier to sort of understand what's happening. Does that sound good? Cool. Yeah. Okay, they didn't include it? Yeah. Okay, cool. Yeah, yeah. Oh, whoops, here.
Hey Josh.
Got it.
I like how you're a person
Yeah,
with
I was
zero
having.
interest.
I know.
Did I do something that was successful?
It was.
So funny if they had. It doesn't sound after. That's not.
All right, folks. Quick recap to kind of pull everything together. So what we did is we ran our overall model, found that we had 2 interaction effects. Those interaction effects said that the unique effect of PTSD on neural functioning changes depending on pain. And then we found an effect that says the unique effect of pain on neural functioning changes depending on opiate use, right? And so by the fact that we have those interactions there, we can say we have evidence of moderation, right? We're saying that these variables do change the nature of these other associations. Then what we did is we're savvy with the algebra. We can go through, deconstruct our models, or sort of restructure our models based on our coefficients in the full thing. We can go through, get our simple slopes, plot our simple slopes. The only thing that we're missing is the tests of these simple slopes at a standard deviation above and below. We're missing that test of the simple slopes and the effect sizes. So what we can do then is go back through and start bending SPSS to our will to go through and test those specific simple slopes at high and low levels of our moderator. Okay, so we went through, did that. Only thing that we're looking at in these simple slopes models, once we make sure that they're correct, is the simple slope of PTSD on roll functioning at low pain, PTSD and roll functioning on high pain. Nothing else in here we're interested in. Again, once we go through and check to make sure that everything's sort of looking good, things. Okay, so got that under control. The other thing we need to go through and do though is we also have an evidence for an interaction of pain and opiate use. Okay, now this one's a little bit different because we've got an interaction that's involving a dichotomous variable, right? Same thing like we went through in lecture last time. We can go through, take our equation, simplify that down, get our simple slopes, plot our simple slopes. And again, this is just simple slopes for my pain by opiate interaction right here, right? Get all that down. The only thing that we don't have is evidence for an effect of pain on roll functioning at high and low level, or sort of for people who are using opiates who aren't using opiates. Okay, now this gets to Abby's question, Johnny's question. Looking at this plot, does it look like we have association between pain and roll functioning for people who are and who aren't using opiates? So based on this plot, it's kind of eyeballing those slopes. Does it look like we have an effect? Yeah, it looks like we have an effect. Looks like it doesn't matter whether or not people are using opiates or not. It looks like there is a negative association between pain and roll functioning, irrespective of opiate use. But what's the nature of this interaction? Why are we getting this interaction here? What is opiate use doing in this, at least in this plot?
Decreasing.
Is it helping a little bit?
What's that?
Is it like helping?
Yeah, it's decreasing. It looks like it's helping, right? Statistical interpretation, conceptual interpretation, exactly right. It looks like for people using opiates, the relation between pain and roll functioning is not quite as strong, right? Not by a ton. It's certainly not as dramatic as what we saw up here, right? And if we look at remember our interaction term is 0.05, it's sort of, we have some evidence, right? But by definition, this is saying the fact that interaction term is statistically significant, it's telling us that we have evidence that the relation between pain and roll functioning is stronger for people who don't have opiates than for people that do. Okay. So what we need to do then is go back, do the same thing. We just need to go through and test. What we want to do is test whether or not we have evidence for, we want to attach p-values and effect sizes to both of these. Okay. So what we're going to do now though, what's our conditional effect? Our conditional effect is pain, right? Look at the effect of pain on outcome, right? So what's our moderator? Opiate use, right? Do we need to take a standard deviation above and below opiate use in this? No, because standard deviation above and below opiate use doesn't make any sense, right? What we do have is we have 0, 1 values. Now, at the start, remember that we centered opiate use to just kind of average across. What we're going to do now is go back through, do the same thing, except now we're just going to create interaction terms with our dummy code 0 and 1 for no opiate use. And then we're going to flip that around and create a new variable where we don't have opiate, where 0 equals opiate use, 1 equals no use. Okay. So if I go up here.
Wait, I have a question.
Yeah.
Why do you have to flip it? Why can't you just keep it the same?
Well, because if I keep it the same, then I'm just looking at, what I want to do is I want to look at the pain, at the relation of pain with roll functioning for people who are using opiates and for people who aren't using opiates. And we need to have 0 represent some people who are using opiates. Do we have a variable in our model that looks at that, captures that yet?
Isn't the opioid variables already coded zero?
Yeah, it's coded 0, 1, but remember, we're always looking at who's our zero value, right? So right now, zero value is people not using opiates. Do I have a variable in my model that has people who are using opiates as 0? No, so we gotta go through and create that, right? And so this is where we're going in opiate use. If I go through and I'll just do this. I'll insert a variable here. If I go through and I sort opiate use, now for everyone who has opiate use equals 0, I'm just gonna put 1.
I don't exactly get why.
Okay, hold on real quick.
You're just swapping it around.
Yep, just swapping it around.
We're doing the centered one, right?
Nope.
No,
Nope, just regular opiate use.
because we want a yes and a no
Yeah.
for this low.
Okay,
Is
so,
there a special way to do the draggy thing?
yeah, that was just a copy and paste down there.
Yeah, but how do you get?
It never worked for us.
Really?
Yes,
I always kind of wondered how you do it.
okay. Yeah.
Oh,
You like just
so I just went through and copied
copy the number 1.
the number
And then
1,
like highlight all of the things.
and then I highlight all of this
Oh.
and then paste.
Oh,
That work?
it looked like you were like dragging the number down and not.
Yeah. Yeah, it does. It looks like you're dragging a certain number.
Okay, you can do that in,
Copy.
you can do that in Excel. Yeah, it's just a cut and copy, copy there.
So what are we doing?
Oh, no, sorry.
Okay,
Thank you.
so all we did with this is we just created a new variable. We have opiate use, that's 0 no use, 1 equals use. And then we just took that and we just flipped that around. So opiate R, 1 corresponds to people who are not using opiates, and 0 corresponds to people who are using opiates. Makes sense.
Why is it important to flip it?
Okay, hold on to that. Just trust me that this is something that you're doing right now.
I trust you.
Okay, yeah, no, we'll get into this in just a moment, okay? So do people got this?
Yes.
Okay, and this is easier to do in some other programs where you just write a code, just kind of recode it. In SPSS with this, it's kind of okay to go through, right? And so then if I go to analyze and I go to frequencies and I look at opiate and opiate use R, these should be the mirror images of one another. And so, yep, on opiate use, no opiate use, 50.2, yes, 49.8. My reverse coded, no, 49, or yes, 49.81 is equal to no, 50.2, everything's looking good. Now what I want to do, so I've got 2 new variables for opiate use, okay? What I'm going to do is I'm going to go through, and I'm going to create 2 new interaction terms, but this time I'm going to create interaction terms. Remember, because opiate use is my moderator, right? And so what I need to do is now go through and swap yes or no opiate use at any point that opiate use comes up in my model. But if I go back to my original equation, the only thing that I've got is opiate use as a sort of a straight effect, and then opiate use times pain, right? So what I'm going to do is I'm going to create a variable that is no opiate times pain, and then we'll say yes, op.
Very Midwestern of you.
Pain. Okay, and then I'm gonna go through and I'm gonna grab my centered pain variable. What did you do, Clem? Whatever.
Oh, you're still in third person by your last name.
Sometimes I disappoint even myself. Center. Pain.
All our own worst critics.
We got centered pain. Times opioid use.
What if you just copy and paste what you have from the?
That would be.
Gotta live on the edge.
Live on the edge.
And then we got the same thing, centered pain.
Right?
Opiate. Get it? Maybe. Opiates are. Okay. Go through. Okay, didn't turn up anything. Okay, so what I've got now is I've gone through and I'm interested in looking at the unique effect of pain on role functioning for people who are using opiates and who aren't using opiates, right? And right now, Mason, when I started out in my original opiate variable, what does 0 correspond to in my original opiate variable?
No use.
No use, right? So what I'm gonna go back through is I'm gonna go through and I'm gonna go back up and I'm gonna build a model. Go through regression, linear, right? I'm gonna go back through. And I'm gonna go through and build this. Okay, I want pain, sure. Opiate use, not gonna use my centered opiate use. I'm just gonna go through where opiate use is equal to 0. Because 0 corresponds to people who aren't using. I got my centered pain, drop centered pain in there. And then in terms of my interactions, I've got pain times PTSD. Is opiate use involved in that? Nope. So I'm gonna drop that in there. And then my opiate use times pain, right? That does have pain. I'm looking at opiate use for people, the 0 value here is people who aren't using opiates. So I'm gonna take my no opiate times pain and drop this into my model. Okay. And I'm gonna hit paste.
Would it make sense slash be nice to like change your variable names for like no opioid use to yes opioid use for your
Yeah.
dummy variable?
Yeah, however you wanna go through and code those so that it makes sense. Keeping this straight in your mind is critical to knowing sort of what's going in stuff. Okay, so here I've got a model that's looking at pain on outcome where opiate use is held constant at 0, where 0 means no opiate use. Okay, what do we need to do then for the other alternative? Now what we're gonna do is we're gonna go through and look at centered pain, opiate R. That's our reverse coded, right? Now 0 corresponds to what? People who are using opiates, right? 'Cause we flipped everything around. But we're using a different opiate variable, so now we need to go through and change my interaction term to reflect people who are using opiates. And now I've got my model, okay? So if I go through and I run this, what I've got now is a model where I've got pain. So I've got pain, opiate use coded as 0, 1, where 0 is no opiate use. PTSD, pain times PTSD, which is our original centered interaction, which is fine. And then my new interaction that corresponds to my original dummy code. No opiate use times pain, where 0 reflects no use. And then the same thing here. Pain, opiate R, this is my reverse coded. Centered pain, my original PTSD times pain interaction. And then the interaction term that has my recoded opiate use with centered pain. And if I do that, right? What am I now seeing? June, what is the only reason I'm running these models? What's the only effect I'm interested in
SPSS crash.
here? Okay,
Um,
don't worry about that.
okay.
Just up here, what's the only reason I'm running that I'm running these models.
To get your little numbers for your simple slope.
And what's the simple slope I'm interested in this example here? Pain. So here, if I go through and I take a look at pain, do I have an evidence for an effect of pain for people who aren't using opiates, right? Because here, opiate use is coded 0-1. 0 means no opiate use, 1 means opiate use. This is the unique effect of pain on outcome, holding everything else constant at 0. Everything else constant at 0 means people who aren't using opiates. Do I have evidence for an effect here?
Yes.
Yeah. Here, again, this is the unique effect of pain on role functioning, holding everything else constant at 0. But this time, Mesa, everything else held constant at 0 corresponds to who? Yeah. So this is looking in the second model, we're looking at the unique effect of pain on role functioning when everything else is called constant at 0. But for opiate R, who does that 0 score correspond to?
Opioid use.
People who are using opiates, right? So this is why we had to create that second variable. What we needed to do is we need to have an alternative dummy code that flops that around. So what we need to have is we need to have a variable in here that sets 0 equal to people who are using opiates, so that we can go through and test the simple slope of pain on role functioning for folks who are not using, or for people who are using. Okay, same thing if we were to be looking at impact of biological sex as our moderator, right? Let's say we have 0-1 women, men, right? And so my base model holding everything else constant at 0, we're talking about women in that situation. But I also want to look at the unique effect of X on Y for men as well. So what I do is I just create a reverse code on that where 0 is men, 1 is women, plug that into my model. And now all of a sudden my model is corresponding as long as I change my create a new interaction term. Now it's looking at the unique effect of X on Y for men, because men is 0 is my reference value.
So is this the same thing as what we did above for high, low, but because it's dichotomous?
Exactly.
Awesome.
Okay. All we're doing is with these simple slopes analyses, we're just changing the value of we're just changing our moderator. All we're doing is to set this at high and low. And with dichotomous variables, it's kind of nice, because I don't have to worry about like high or low or what level of slope. It's just for this group versus that group, which simplifies things quite a bit. Okay, now to roll this back, Kate, if I would have gone through and not centered opiate use and just left opiate use as 0-1 and used that dummy code in my base model, what would I have in terms of the effect for pain in that base model?
We have what we have.
It would have what we have here, right? Basically what that would do if I didn't center that to start out with, I would just start out with the effect of pain would just be my simple slope for non-opiate users. Okay, now I didn't want to do that because I didn't know if there was going to be an interaction. If I include this in there, it's going to change that coefficient a little bit because it's going to make it specific to people who aren't using. So I went through, took the mean of that, like centered it to say, well, in my base model, just give me the average effect of pain on outcome controlling for opiate use, right? But we did come up with that. So now what I'm doing, going back through, rerunning my model with the original dummy code, and then running it again, flipping it around using the reverse dummy code where 0 equals opiate users, 1 equals non-users. Okay. So do people see, Haley, you see why we sort of went through and why we have both options? Because again, it's just controlling what's 0 in our model. And so long as we do that, now all of a sudden, all of our main effects here represent the unique effect of that variable on our outcome. Everything else held constant at 0. And then we just got to think, what does 0 mean? In this, 0 means non-opiate users. Here, it means opiate users. Kind of see how we're just manipulating the model to go through and get what we need out of this. Yeah, Johnny.
I'm getting a little bit like why we're saying that opioid users is actually like helping.
Well, conceptually, that's kind of what we would, and so then if we go through and we take a look at this, so Johnny, do we have evidence for effects for both of these? Yeah, right. And so this is what's gonna happen. We see that irrespective of opiate use, pain severity is related to reductions in functioning. It's just that association appears to be weaker for people who are using opiates as opposed to those who aren't. Now, I think I jimmied around with these data a little bit so that they kind of make some sense. If people are using opiate use for the management of acute pain, then I would hope that using a pain reliever would improve my functioning a little bit, not a ton. Now, in actual practice, what happens as people, at least were using these at the time that we collected these data, that's not necessarily the case, right? But just to make this an example that kind of makes some conceptual sense. So here, as opposed to this example, right, where we've got at low levels of pain, you see PTSD related to reductions in functioning, right? At high levels of pain, it doesn't matter. Like at high levels of pain, people just aren't functioning at all, so we don't have any effect here, right? Different type of effect. Here, we see that pain is related to PTSD or related to role functioning, reduced functioning, irrespective of whether or not people are using medications or not. It's just for when they are using medications, it looks like that relationship isn't quite as tight, which we could interpret to say, it looks like, at least based on these data, there may be some benefit for taking medications in that it just decouples this a little bit. It's still related pretty strongly, right? If we go down through and take a look, for pain use, you know, our partial correlations are still pretty strong for people who are not using and for people who are, but it's just a little bit lower. That helped clarify that?
I think so. I think I was getting confused just because like in my head, I was seeing a larger number for the coefficient for pain for the non-opioid use. Does that make sense? And I think I was just getting confused on like, wait, what are we looking at?
Okay.
And so you're saying that it makes sense because the opioids are essentially like acting as somewhat like a buffer between those two.
At least in this example.
Okay.
Yep. And so we're saying a larger negative value for no use, indicating a stronger connection than for people who are using. Still negative, still pretty large T statistic, real small P value, but not to the degree for people who aren't.
Okay,
Okay.
thank you.
Yeah. Other questions? Okay, so with these moderation examples, and again, we'll have,
So I have one last
Yeah.
question. When you hand calculated the simple slopes, that's what we change. So you have like yes at negative 0.5, I mean at 0.5 and no at negative 0.5.
Yeah.
Those would change depending on the splits of our data, true?
Yes, yes, absolutely, absolutely. Right, and the where you go through and get that, just pull up in your data and just look, because it's dichotomous, right? People will have two values. What are the two values are in the data set is what you put in there. Okay. So as we're working through these models, a lot of things and pieces and parts to kind of keep together and manage. You will make mistakes. That's fine. Just make sure as you go through, remember those slides and sort of like saying, okay, if I've done this correctly, if you've done things correctly, that your model should behave in a very specific way. Some things should change and some things won't change. So long as you can use that and say, okay, this is what changes around, you're going to be in good shape. Okay. What you want to do is if there's a mistake or you've gone through and something isn't quite right, just being able to say, oh, whoops, let me go back through, see what's going on, where things sort of coming up is kind of wonky. Okay. But whether or not we're using continuous moderator, dichotomous moderator, doesn't matter. We're still kind of taking the same approach. It's just if we have a dichotomous moderator, then it kind of gets easy because then we're just flopping around sort of one way or the other way, versus having to fool around with sort of standard deviation above and below. Okay. Also, the other thing too, remember that once you go through and you have your original model, this is your same model. This is your model for always and forever throughout the end of all of your simple slopes. Your R squared shouldn't change, your F shouldn't change. What you can do is make sure that, okay, I'm interested in looking at the interaction of probing this interaction of pain and PTSD. I'm using pain as my moderator. PTSD is my conditional effect. So I need to go through where do I have pain? All right, I need low pain, high pain here. I got pain involved in this interaction, so I need a low pain, high pain interaction here. Pain's here, I need a low pain, high pain interaction here. I don't care about this interaction, but I need to go through and make sure that, because then otherwise I've got an interaction term that's working with a different variable than the other stuff, and then that'll fool with things. Okay, so just make sure that those two things, and then same thing here, opiate use times pain, conditional effect is pain. Now, opiate use is my moderator. Okay, where do I have opiate use? Here, need to go through and make sure I have things changed there, just as a system to kind of keep you on track, making sure you're following the pattern. But this is sort of your sort of base model that everything should be sort of tied into. And then when we go through, and this is why I think particularly as you're learning to do this, hand factoring these out is important, because one, it gives you a sense for what's going on with stuff. And then two, it gives you a fail safe for going through and checking your actual model that you get in SPSS. The model that we get here, or the simple slopes model that we get here, follows the same constants that we get sort of out of SPSS. Okay, same thing. Simple slopes that we hand factored here turn out to be identical to what we got out of SPSS. Okay, so it's a nice just secondary check to be able to say, are things turning out the way that I wanted them to? Yep, cool, we're good to go. Okay, all right. So we've got this example that we went through, got an example sort of in a screencast demonstration and things like that. We've got the one that we just did here. You've got your handouts. Also, we've got an additional that moderation 2 data set. That was for just like different example with different variables. I think it's 2 continuous moderators in there, walking through the same thing with examples and factoring out and stuff like that too. So if you're feeling uncomfortable, feeling like another example would help, you can go through and walk through that one as well too. Okay, with the handouts and sort of everything that kind of goes with it. Awesome. Okay, so talk about standardization, standardized solutions here. Just remembering that for your model that you just run in your base model, if you go down through and look at your standardized regression coefficients, those standardized regression coefficients are fine until you get to the coefficients for your interaction terms. Those aren't fine, because what those are is the z-score of your interaction, as opposed to the product of the z-score of x and z-score of y. And so if you want to get a standardized solution, what you need to do is rerun everything that you did originally, do the same thing, except for just use z-scores, right? So z-score of x, z-score of y, then go through, recreate your interaction terms with your z-scores, and then just go through and run that model with those interaction terms, okay? You don't have to worry about simple slopes with this necessarily, because your simple slopes are fine. The only problem is just the for that full model, the interaction terms, the standardized coefficients for your interaction terms aren't technically correct. That's where you would go through and do this. Okay. All right, so gonna run through this quickly. This is really cool. All right, in psychological, sort of in the way we go through and do things, we take this simple slopes approach, right? So when we're probing these interactions, we're looking at the unique effect of x on y at a standard deviation above or below the mean, right? Problem is we're just looking at the association of x and y and kind of 2 arbitrary variables. We just have picked 2 points, right? People see people criticize this to say, well, it's a pick a point thing, right? There are these a standard deviation above and below, if it with a continuous moderator, just 2 points out of an infinite number of points where we could actually go through and look at the conditional effect on X and Y, okay? And so if I really wanted to make those slopes look different, I could just start to choose increasingly large values of my moderator, and those will get increasingly different, right? Now, if you report that and like, oh, I looked at this simple slopes at 3 standard deviations above and below the mean, someone's gonna flag you back. Why would you do that? There's no one existing out there in that tail. It's a weird hypothetical, right? But just because the standard deviation, there may be situations where there's some critical point of your moderator that starts to make sort of conceptual theoretical sense. Like maybe I really don't care about a standard deviation above or below. Maybe there are these other points that are interesting to me. Or maybe I want to see with that negative relation between PTSD and role functioning, like how severe does your pain have to be before we just stop seeing an association between those two? We don't really get that with that pick a point approach, right? Here's where we got our Johnson-Neiman procedure, okay? What we're doing, instead of plotting our simple slopes at 1 or 2 values, what we're doing here is we're looking at the conditional effect of X on Y across the whole range of moderators, okay? This is gonna give us a different graph. It's a little bit tricky to interpret, but once you kind of see what's going on, this is an incredible amount of information here. So I did this in Stata because I don't know how to do it efficiently in SPSS. You probably, there's a macro for it maybe or something like that. But essentially what we're doing here is I'm looking at the unique effect of X on Y at a whole bunch of like 200 some different values, okay? And so here I have my simple slope at all these different values of Y, okay? What I'm doing here is I'm looking at the conditional effect of X on Y on ranges of, on values of my moderator, ranging from 0 to 9, because maybe that's my full scale, at 0.05 unit intervals, okay? So this is just part of the output. This is however many, close to 1,000 values there is. Looking at that simple slope as it changes incrementally at 0.05 intervals of my moderator, ranging across the whole value of my scale. Okay. So here, this is from Layla's dissertation, or excuse me, her thesis. Layla was interested in looking at the relation of PTSD and social functioning at different levels of empathy. Okay, and so she went through and she found an interaction of empathy and PTSD on social functioning. And we plotted this out using our standard simple slopes, right? So here we have evidence for a negative relation between PTSD and social functioning at low levels of empathy. So at low levels of empathy, as my PTSD increases, my social functioning decreases, okay? But here, it's a little more ambiguous. At high levels of empathy, is there an association between PTSD and social functioning at high levels of empathy? I don't think we didn't find evidence of an effect there, right? And so this is how we would go through and take a look at this. And this is fine, right? So here, standard deviation below is at a level of 3, standard deviation above, a value of 8. So here at high level or at low levels of empathy, we have evidence for an effect. At high levels of empathy, no unique association of PTSD and outcome for social functioning here, okay? So fair enough. This is how we would generally do things. But maybe I'm interested, like, at what level of empathy do we stop seeing an association here, right? Or what about other levels that aren't represented at these 2 values? We throw up my Johnson-Neiman plot, we get a little bit something different, okay? On my X value, on my X axis here, these are values of my moderator from 0 to 9. And what I've done here is just plotted this at 0.05 unit intervals. And then my Y axis here, this is my simple slope. Y axis represents the simple slope of PTSD on social functioning at different levels of empathy, okay? And so what we do is we have our line, and then we've got confidence bounds around that line, okay? And so what I can do is I can say, okay, well, at a standard deviation below right, is equal to 3. Here's my association. This is the point estimate for my relation of PTSD and social functioning. It's negative, so I have a negative value. And do I have evidence for an effect here at this level based on those confidence bounds? If 0 is my red line, if that's sort of 0's effect.
Like serious effect, like.
Or yeah,
threshold.
0 is like actual, like the simple slope is equal to 0. So do I have evidence for an effect here?
Yes.
Yeah, right, because here's the lower or the upper bound of my negative, so I have evidence for an effect here, right? And if I go through and I take a look at 8, right, here's my positive slope. Here, my point estimate is still negative, right? But do I have evidence of an effect there? For this, if we're looking at the confidence bounds.
That's the red line.
Yeah, so no, right? So
Yeah.
0 is contained in that confidence bound, so I don't have evidence for an effect here, right? But there's a whole range of stuff going on in here where I can start to ask questions about the relation of PTSD and social functioning at different levels of empathy, right? What if I wanted to know at the cusp, maybe like at what point does PTSD stop holding an association with social functioning? At what level of empathy do we stop seeing a unique effect of PTSD on functioning? Where would that be on this graph?
In between.
In between, yeah, but
Somewhere in
it's
between.
looking at that confidence
Oh,
bound
like where the red line
Yeah,
probably
right
stopped.
here, right? Right here. Right here's where that upper bound of that confidence bound hits that 0 point. We know if a confidence bound contains 0, then we, by our rules, we don't technically have evidence for an effect. So right here, if I go through and take a look, and I go through and look through my plot, this is about 6.75, right? So at about empathy score of 6.75, this is when PTSD stops holding an association with functioning, okay? Which is kind of cool because it can tell me exactly how much empathy I need to have before we stop seeing the relation between X and Y, right? Now, if I'm looking at this, Allison, so this is right where, like, my upper bound of my confidence bound just like ekes under that 0 point. Am I super confident that that's the value of empathy for always and forever, that it will sort of be there? Probably not, right? I'm like, for these data, that's exactly where that bounds. If I were to do this again, that confidence bound might equal above, it might be a little bit low below. So maybe I want to see, like, what point do I have strong evidence for an association between PT that sort of that caps off? So I can go through and take a look at that. And maybe if I'm using, let's say, a Bayes factor of 10, right, as sort of evidence, I go through, get a Bayes factor that's close to that, gives me a value of about 6.15. Okay, so I might say, here's where, and so my upper bound of my limit, we don't contain 0, right? And it's a ways off, but maybe you say, okay, at a value of 6.15 on this empathy scale, this is where I'm no longer seeing an association of my effect. Yeah.
Just a quick question. So on the x-axis for empathy, are those true values of empathy?
Okay, and then that starts to get into another thing. So here I have strong effect, but is 6.15 a real value that I can get on that scale, right? Nope, it's not, right? So what do I go through? What's a real value? I can have a value of 6. Well, value of 6 just kind of falls sort of right there, right? But then maybe I say, well, what about at average levels? At average levels, so what's my conditional effect of PTSD on role functioning at average, or excuse me, on social functioning at average levels? Here, we got an average level right here. So what we can do is we can start to go through and describe that the association, that simple SOAP, that unique effect of my conditional effect across the whole range of outcomes, as opposed to just 2 random points that we select, which makes this super, super, super cool, okay? And what we found in this is that, so empathy here has an average value of 5, right? So on average, people have values of 5. It's not until we get to like 6.5, almost a value of 7, like just at the top of the scale where we stop seeing an association here, which tells me that basically PTSD has an association with reductions in social functioning for mostly everybody, except for those people who are very, very, very high in empathy. Once we get to these very high levels of empathy right here, then we stop seeing an association. But everything below that, we're seeing a unique effect here, which starts to tell me a little bit more about the phenomena of interest and where those boundaries are and things, as opposed to this is fine, this is what we typically do, but limited in a lot of ways. Okay, so I'm not gonna have you go through and do this. Here's procedures for going through and doing this in state. I have a demo, Johnny, if you ever wanted to go through and take a look at this. I'm not sure how you would do this in SPSS. There's probably macros available. I think process will do this if you set it up right. But a cool thing to go through and explore and really kind of jazz up, and so be able to pull out interpretive stuff for your moderation analyses of it. If you have a continuous moderator. For dichotomous, it doesn't make any difference because you just have two values, right? But for continuous moderators, this is quite good.
Do you know if that's an R?
What's up?
If that's like a.
Oh, for sure, everything's in R. You can go through and find it in R, 100%. So.
We gotta send IBM a message about
They'll put together a funky interface.
that. Any other things?
Okay. Last thing we're gonna finish up with today to get everybody kind of solidified in terms of going on set 3. Moderation with multi-cotomous indicators, okay? What we can do is we can start using dummy codes to look at the interactive effects of categorical variables having 3 or more variables, okay? Let's say my moderator is let's see, we're doing like an experiment, and I've got control condition 0, condition 1, condition 2, right? So I've got a nominal variable with 3 levels. Can I just dump that into a regression model? No, I can't. That's not going to work, right? Well, what I can do is I can start to recode that to start to look at specific things in ways that can start to be effective. What I'm going to do is I'm going to dummy code that categorical variable so that I have 0, 1 codes, so that I'm going to get a comparison of some reference group with every other group in the model. Okay. So this is an example pulled out of Aiken and West in that sort of tiny book that is kind of nice in terms of like looking at what's going on with these types of regression models. So here they've got some data looking at the relation of degree, program, and GPA on eventual salary. Okay. And so the question here is, what is the unique association of degree and GPA with starting salary? And then does degree moderate the relation of GPA and starting salary? Okay. Degree is a categorical variable. It's not continuous. It's sort of like, there's no sort of rank order things. It's just like different people have different degrees, right? So within this set, we've got degree variables. We've got a liberal arts degree, we've got an engineering degree, and then we've got a business degree, coded 1, 2, 3, okay? What I'm gonna do, now I can't just do anything with this. I can't sort of plug that into a regression model. It's not gonna make any sense. What I can do is I can create 2 dummy codes that sort of specifies a reference group and 2 comparison groups. So what I'm going to do is I'm going to create a dummy code here that's a dummy code for engineering. And what that's going to be is it's going to be a value of 1 if someone's an engineer, a 0 for everything else. That means if someone's a liberal arts degree, a business major, they get a 0. Okay. Then I'm going to create a second dummy variable, 1 if it's going to be for business, 0 if it's liberal arts or engineering. And then my liberal arts group, this is going to be my reference group, okay? When you're creating dummy codes for a categorical variable, you're going to take the number of groups you have, subtract 1, that's the number of dummy codes that you need to go through and categorize that. So if I have a dichotomous variable, I just need 1 dummy code. I've got 2 categories, OP use, not OP use, just need 1, right? Here we've got 3 levels, so we need 2 dummy codes. We got a 3 level, we need, or excuse me, 4 levels of my categorical variable. I need 3, right, to go through and set that up. And so here you can see we've got people, here's the degree variable. And what I've done is just sort it the same way I kind of did before. And anybody who has an engineering degree gets a value of 1, everybody else gets 0s. Here, anybody with a business degree gets 1, everybody else gets 0s. Okay. Yeah, okay,
And then so in the degree category, anybody who has a 1 there is liberal arts?
yeah.
Okay.
Yep, so if you see anybody who's got a 1, 0, 0, 0, 0, 0, 0, 0, 0, right? And so what this is your reference group. And this starts to become important when we get into this next slide, okay? So what happens if I go through and I regress starting salary only onto my dummy codes, okay? So I've got 2 dummy codes. I've got a dummy code for engineering and a dummy code for business, right? If I go through and I run this regression model where I regress income onto my 2 dummy codes, I get an intercept, a coefficient for engineering dummy, and a coefficient for business dummy. Okay, business dummy, engineering dummy, all those are okay. This is the equation that I get. Okay. If I go through and I take a look at this, my individual coefficients, beta 0 is my mean salary for liberal arts. Why?
Because it's your reference group?
Because it's my reference group. Exactly right, Danielle. If I go through and I put in 0 for, if I put in 0 for engineering, I put in 0 for business, who am I talking about? Liberal arts folks, right? And if I put in a 0 here, this goes away, 0 here, this goes away. I'm left with my intercept. This is just the expected value of y when everything else is held constant at 0. When everything else is held constant at 0, I'm talking about my folks with liberal arts, right? So this is why I only need, if I've got 3 categories, I only need 2 dummy variables. Because if I have a person who scores 0 on this one and 0 on this one, who am I talking about? My reference group, right? So here we've got the mean salary for liberal arts. My coefficient here for B1, this is just the difference in the mean salary for engineering versus liberal arts, right? So basically, I'm saying that engineers are making about $7,000 more starting salary than someone in liberal arts. These data are dated, and this that value is actually quite a bit larger than that. But what we're saying is, based on this model, starting salary for people with an engineering degree is $7,000 more than liberal arts. And if we take that and add that together, that gives us our mean salary for engineers. Right? Just talk about that. And then my last B2, this is the difference in my mean salary for business versus liberal arts, right? So here, basically what I'm doing, right, if I have someone who's a business major, I've got 21,000, that's 0, so that goes away. This is 1, my salary is those 2 added together. Okay. So my regression model, my overall regression, my R squared is saying testing the hypothesis that salary does not differ across degree. If salary didn't differ based on our individual degree categories, then this would be something close to 0, this would be something close to 0, and then everybody's the same, right? But instead, when I regress starting salary onto these 3 dummies, what it's giving me is the expected value for my reference group. And then my coefficient for my first dummy is the difference between my reference group and my target group, difference between reference group and target group. And if I want to get sort of the expected value for each one of these, then I just add in the intercept. Basically, we've got an additive model here where we start out with the level of pay or starting salary for my liberal arts folks, and then we're making adjustments up and down based on their degree program. Okay. Now, what if I were to find an evidence for an effect of my engineering dummy and not a business? What would that tell me?
The engineering compared to, so the salary for engineering compared to the salary for somebody with a degree in liberal arts is higher?
Is
Or-
higher,
yeah.
but for business, looks like they're about the same. Right? What kind of analyses did I just do here? Functionally, what is this? What do you think?
Gonna say a t-test
Okay.
or ANOVA.
An ANOVA, right? What we've got is an overall ANOVA. We ran an ANOVA model. We've looked to see, are there mean differences in salary across these groups? And then individually right here, we've got like functionally like a t-test between engineering, liberal arts, business and liberal arts, right? Again, ANOVA t-test, just a special case of regression. We can go through and run this in no matter how we want to do this. Okay.
I just have a quick question though. I'm just having a hard time, like, yeah, this is a regression, but, so of course, like our outcome variable would be salary, our predictors would be degree. What is the moderation, I guess?
Haven't got there yet.
Oh, okay, good. I was like,
Yeah.
okay,
This is just the straight, this is just straight simple effects sort of dummy, right? Essentially what we're doing is we're running an ANOVA model in a regression format. And it's actually kind of slick. If I just run my ANOVA model, I say, if there's a difference in there somewhere. But then I gotta run some follow-up tests to go through and see. Here, I'm getting my overall model. Does it differ? That's a test of my R squared. And then sort of individual comparisons within this. Okay, so it's pretty slick. Okay. What I can also do then is go through and layer in centered GPA. Okay, let's say, okay, I see differences in these different degree programs. What influence does centered GPA have? So I go through, regress my starting salary on my two dummies and centered GPA, and this is the model I'm getting. Right here, we get my coefficient, my intercept is my mean salary for liberal arts with GPA equals to 0. In this model, what does GPA equal to 0 mean? Average, right? Does anybody get degrees with GPAs equal to 0? No, right? And so this doesn't make any sense, right? So what we go through and do is we center GPA, and now we've got the expected value, starting value for liberal arts majors at average levels of GPA for this sample at least. My beta 1, the difference in mean salary for engineering and liberal arts controlling for GPA, right? B2, difference in mean salary for business and liberal arts controlling for GPA, engineering and liberal arts, business and liberal arts. And then here, B3, this is the change in expected salary per unit change in GPA for my liberal arts group, right? Because again, this is a unique effect of X on Y, holding everything else constant at 0. If I hold everything else constant at 0, who am I talking about? My liberal arts folks, okay? But does this coefficient change depending on who I'm talking about here? No, not with my first order effects, because there's no way for this to do, because we don't have any interaction effects here, right? So what we see, if I look at the unique effect of GPA on outcome at each one of my, for each one of my groups, it's all the same, right? Now, I don't know that it's all the same, but my modeling can only make it the same because there's no way for degree to influence this here. See what I'm saying? Okay. So what we can do then is now we can go through and put together a model, Haley, that gets at this interactive effect. Okay. So what we've got here, if I start to include interactive effects, I've got the multiplicative effects looking at differences in the relation of GPA across different starting salaries. So here we have my intercept, and then my dummy for engineering, my dummy for business, my centered GPA variable, okay? And now I've got the interaction of engineering dummy times centered GPA and the interaction of business dummy times GPA. Okay. And again, if I look at these and think conceptually what these interaction terms are looking at, it's saying, is there a difference in the unique effect of GPA with starting salary? Does that differ across engineering and liberal arts? Okay. Does the unique effect of GPA on starting salary differ across people with a business degree versus liberal arts? Okay. Should we go through and center any of those dummy codes there? Absolutely not. Absolutely. If we center dummy codes for a categorical variable like this, it screws everything up. They become uninterpretable, right? So we just got 0, 1 codes with this. If we go through and we run this, this is the model that we get here. Okay. And so if I go through and I run my simple slopes, this actually starts to become pretty easy. Then I just start throwing in 0s and 1s wherever I need them to be. Simple slopes for my liberal arts group is just 2982 times 790, right? Again, this is the unique effective GPA on outcome. Everything else held constant at 0. So I've got 0, 0, which means I'm talking about liberal arts. That's 0, that's 0. All that goes away. All I'm left with is this. Simple slopes for engineering. Again, my intercept comes down. Engineering was 1, that comes down. Business is 0, that goes away. This is my conditional effect that I'm looking at, so that comes down. Engineering is 1 here, so that gives me 667 times GPA, that's 0, that goes away. Gives me my equation for my simple slopes for engineering, right? And now I've gotten the simple slopes there for engineers relative to liberal arts folks. And then the same thing for my business, right? I'm just going through plugging in zeros and ones. Okay.
Any reason why liberal arts was chosen as the reference variable? Is it like the lowest of them would be?
Yeah, in this one, that's just the way they did it, but that's a conceptual question. What you want to set as your reference group is really up to you. So if Gabe's running an experimental study, you've got control and two active conditions, then probably that's the one that makes the most sense. Generally, or oftentimes you'll have something like a control group that's people who don't have whatever you're looking at, or like something along those lines, right? But what we're doing here with this dummy code approach is it's giving a specific contrast between some target and my reference group.
Hey, Josh, I just have a quick question. So when you are regressing the dummy codes and just looking at that, would you do like a hierarchical like step approach and do a one, or would you just put them all into the same model, like regress model?
This you have to put them all at the same time.
Okay,
Because if you leave one out, then all of a sudden, then my dummy codes fall apart. I need to have all.
so they
those.
always have to.
They always have to all be in there, because then if I just look at regress starting salary on engineering, I mean, I guess it just gives me the difference between engineering and everybody who's not an engineer. Right, but if I have engineering and business, now all of a sudden, both of these make some sense in terms of reference to my reference group. What happens if I put in a dummy code for engineering, business, and liberal arts? Everything falls apart. Because if I know what this is and I know what this is, then that other thing is already predetermined, and you've got collinearity issues and things fall apart. So again, my coefficients here, 0 B naught is my mean salary for liberal arts at average GPA. Here, I've got the difference in mean salary between engineering and liberal arts at GPA equals 0. Difference in mean salary for business versus LA at GPA equals 0. This is a change in expected salary per unit of GPA for liberal arts, right? Thing is, all of these things right here are dependent on what you set up in terms of your dummy codes, okay? Here, B3 plus B4, association between GPA and salary for engineering, B3, B5, association GPA and salary for business, right? And so again, if we just start using, just like very literally start plugging in zeros and ones, thinking about what 0 means, all of this stuff starts to fall out pretty quickly. These things. So people seeing interpretation of my overall model. So then if I want to go through and test my simple slopes with my dummy codes, all I'm going to do is the same thing we did for like the opiate example. I just start changing around who my reference group is. Okay. So my simple slope for liberal arts, this is just the test of B3 in my original model. The unique effect of GPA on starting salary when everything else is held constant at 0, everything else held constant at 0. That's my folks who are in my liberal arts group, right? Simple slope for engineering, right? How am I going to get a simple slope looking at the effect of GPA on starting salary for engineers? Well, what I can do is I can just rerun my model. And so now I've got a dummy for liberal arts where 1 is liberal arts, 0 is engineering or business. And then a new dummy code for business where 1 is business and 0 is liberal arts versus engineering, right? I can't use my original dummy code. My original dummy code is business. Well, I guess you could. Yeah, but this just kind of switches things around here, right? And so now if I go through and I rerun this, where now engineering is my reference point, that coefficient looking at the unique effective GPA on starting salary now refers to my engineers. Same thing for my simple slope for business. Again, I've got my dummy for BA, got a dummy for engineering, and now B3 in that revised model is looking at the simple slope of the association of business or GPA on salary for business. And so essentially what we're doing here, if I want to do this, right? So if with this dummy code model, I get comparisons of, in the first model, it gave me comparison of engineering and liberal arts and business and liberal arts. And so then I already have my simple slopes here, right? If I want to test my simple slopes specifically for engineering, then I just swap around my dummy codes, make sure my interaction terms are appropriate, and then just run my model. And now my coefficient for GPA corresponds to engineers. And if I redo that again, this time using business as my reference group, making sure my dummies are correct and my interactions are correct, right? Because then I'm going to have an interaction in this model. I'm going to have an interaction of my dummy for liberal arts with GPA, centered GPA, dummy for interaction of dummy for business times GPA, new model, going through testing, same thing here. Okay. And so if I go through and I do this, is I go through and I see now that for engineers, starting GPA doesn't really make a difference, right? It doesn't really hold an association with starting salary, which kind of makes sense because you make it through an engineering program, it's just like, you're good, right? And you go through and get a job that makes more than we ever will, it's fine. Life choices, right? But so no effect there. Now, if we go down through and take a look at the effect of starting GPA on starting salary for liberal arts and for business, now we're starting to see some positive effects, right? But here with these interaction, whoops. Here with just our first order effects, we couldn't actually test that. We couldn't see if there were differences. Doesn't mean that they're not there. We just didn't give our model an opportunity to give us tests to see if they were there, right? But if we go through and just add these interaction terms, right? Here is our model that's going to give us, for this coefficient for GPA, is going to give me my simple slopes for GPA with starting salary for liberal arts, because liberal arts is my dummy, or is my reference group in this dummy code. But if I want to get the simple slopes of GPA on outcome on starting salary for business or for engineering, I just reconfigure my model so that I've got a dummy for liberal arts, dummy for business, liberal arts times GPA, business times GPA, and now engineering is my reference group, right? Or if I want it for business, I've got dummies for liberal arts, dummies for engineering, liberal arts GPA, engineering GPA. Now business is my dummy, and this is now giving me the simple slope for that. Okay. So it's actually kind of a pretty slick system to go through and take a look. Again, it all falls back on understanding what's my zero value, what does zero represent, and then anytime I'm looking at anytime you're looking at a regression model, this is always representing the unique effect of X on Y or the predictor on Y when everything else is held constant at zero. So in your mind, you think about, okay, what does that mean when everything else is held constant at zero? It could mean actual zero. It could mean average levels. It could mean a standard deviation above. It could be a standard deviation below. It could be for whoever's at zero in my sort of dummy, right? So just going through and thinking carefully about what this means and how it all comes together. Okay. Questions? All right. One thing that's kind of an interesting question that we want to think about. Sometimes if I have an X and a moderator that are highly correlated with one another, what I might get is something that looks like a moderation effect. It actually masks a curvilinear relation. okay? So if I think about if X and my moderator, if X1 and X2 are very highly correlated, if I take two highly correlated things and multiply them together, if they're particularly on the same scale, it's kind of about the same thing as an X squared. This is a very different type of relationship, right? So one of these things that you want to go through and think about in terms of, if I'm finding interactions, is it possible that I actually have a quadratic effect there? That I have some sort of nonlinear U-like shaped relation between some predictor and an outcome? It can let's talk about ways to go through and start to tease this apart. We're not going to worry about this a whole lot, but it should be something that you're keeping in the back of your mind when you're seeing some of these moderation effects. If you have very highly correlated predictors, hopefully with everything we've talked about, you're not going to have very highly correlated predictors. So hopefully this is a non-issue, but this is something that you should be thinking about. Let's say someone presents a paper where they're saying, oh, neuroticism and self-esteem interact to predict something. Like, well, I don't know, depending on how you measured that, maybe neuroticism and self-esteem are actually the same thing. And what you're actually getting is a curvilinear relation between neuroticism and, let's say, performance, right? Low levels, performance isn't some great, good, reasonable, healthy level of neuroticism, stuff improves. Neuroticism gets too high and now performance goes down, right? So one, to think about this as a mathematical possibility, right? Really what you want to think about from a theoretical perspective, does this make some sense, okay? So something that's hanging out there in the background that we should probably be thinking about, alternative explanations for what we're having. Generally don't need to worry about this unless you have very highly correlated predictors. But if you do, something to sort of keep an eye on. Okay. Gonna finish up real quickly in terms of thinking about power, reliability, effect size and stuff. Again, effect size is here thinking about indicating magnitude of an association of population. Think about this sort of specifically. I don't know. I like thinking about this. An effect size is the extent to which the null hypothesis is false, right? If I have a small effect size, it means the null hypothesis may be false, but maybe not so false. A really big effect size, like, oh yeah, that null hypothesis is really not accurate. Okay. Think about power. Power being the long-term probability of rejecting the null hypothesis. If we were to do this again and again and again and again, how often of a sample of this size with effects of these size would we expect to identify an effect using the standards that we do? Okay. Again, underpowered analyses increases the likelihood of failing to reject the null when the null hypothesis is false. Like this is the big problem we have in psychological science, right? Thing to remember about moderation. Moderations are notoriously underpowered, okay? Anytime we're trying to find a moderation effect, these interaction effects probably from a theoretical perspective are already pretty subtle. Subtle influences on behavior. We've got so many different things that go through and influence how things are related to one another. These tend to be very subtle effects that can be difficult to detect, okay? So we're already starting out with small effects. Then what happens is we start to compound this with measurement error and poor reliability. Okay. Let's stop at that. That'll be good. We don't need to get into, we'll save the rest of this stuff for next time. But essentially what goes on is when we're using interaction term, or when we've got variables that have less than perfect reliability, right? If we're thinking about your alpha level, your internal consistency, right? If I have an internal consistency, the reliability of my interaction effects, if I take sort of variable A and variable B and multiply it together, the reliability of that interaction term is the product of my two reliabilities, right? And if I have two variables that have reliabilities less than perfect, less than one, what happens if I start multiplying decimals together?
And when you start multiplying decimals together, yeah.
If I start multiplying decimals together, what happens to the product of those? It gets smaller, right? So if I have a measure X that has a reliability of 0.8, and I measure a mediator or moderator has a reliability of 0.8, We're excited about that, right? Like, oh, this is good reliability. What happens when I multiply those two things together to get an interaction term? What's the reliability? Yeah, interaction term. 0.64. If I take 0.8 times 0.8, 0.64. Are we excited about reliability 0.64? No, right? And so now all of a sudden, not only are we looking at effects that are very small and hard to detect, and we need large samples to go through and detect, we've also got interaction terms that are that have pretty poor reliability because they're the product of my two component terms. So now all of a sudden, we're trying to detect an effect for something that has poor reliability and oftentimes an underpowered study. And so it starts to become very, very difficult sometimes to detect these effects, even when there's maybe effects to be found. Okay, so we'll pick up there. Everything else with this lecture is just additional information that you'll need to know, or that we'll sort of talk about when we get back, not things you need to worry about in terms of the completion of your actual set. So we're in a good spot. We'll pick this up next Wednesday, finish this up, and then go through and get through mediation stuff. Mediation stuff is pretty quick and easy. It's actually much, much less computationally intense than all of this stuff. Okay. So keep working. Again, I'm gonna be out tomorrow through Monday. But run into problems, shoot me an email. No one's looking up a lot of the phone, better respond to people and then get you squared away with stuff like that. So go through work. When Matt gets this next set finished up, he'll kick that back to you so you can have that to go through and look at. And then again, you have to have questions about interpretations or anything like that. Shoot me an email, I'll probably be less prompt than I typically am because I'm going to be out away, but I'll sort of get you set up with stuff. I'm going to San Diego. It is, because I got COVID for Tara's 40th birthday, and so that we couldn't go.
So it's like a baby moon.
It's it made a birthday to see friends in San Diego, but
And the baby moon.
and a baby. We, I don't know, it's hard to say, like, we could still get snowed.
Don't you jinx yourself,
Well,
John.
this is a jinx trip, but it's been canceled twice already.
Good energy into the atmosphere.
Good vibes.
So, all right, thanks, everybody. This is tricky stuff, and it's can be difficult to wrap your head around.